Differential and integral operations 4, we will work on the last part, which is curl of gradient of f is 0 and divergence of curl is 0. Curl A is 0. Okay, so let's start with curl of the gradient. Curl of the gradient of f is 0. That's what we're going to show. Okay, so how do I write curl using subscript summation notation? Epsilon ijk ei hat del xj, and then I have the k component of gradient of f. And this can be written as epsilon ijk ei hat del xj. For the gradient of fk component, we have del f del xk. Okay, and now I'm going to call k, j, and jk. So epsilon ijk. So let's first switch the order of the derivatives. This is ei hat del xk del f del xj. I can switch the order of the derivatives, that doesn't matter. And then I'm going to call k as j and j as k. So this is going to give me, instead of epsilon ijk, epsilon ikj ei hat del xj del f del xk. All right. And now I will switch the positions of k and j, and that introduces a factor of -1 because this is an odd number of changes in the positions. We have minus epsilon ijk. Remember, I, k, j here. So if I go from I towards j and k, this is going to be in the negative direction. So here is the minus direction. Etc. So this is going to be minus epsilon ijk. Ei hat del xj del f del xk. Okay, so now you can see that the first thing here, epsilon ijk ei hat del xj del f del xk, is equal to minus epsilon ijk ei hat del xj del f del xk. And if x is equal to minus x, this implies x must be 0. Therefore, we can conclude the gradient, the curl of the gradient f, curl of gradient of f must be 0 as suggested. And let's work on the second one, which is the divergence of the curl. Divergence of curl A. This must be 0. Okay, so using subscript summation notation for the del operator, I have del xi ei hat. That product with, that's the divergence, this vector curl A J EJ hat, which is curl A. And that means EI hat dot EJ hat, and that is going to imply that I is equal to J, so we will have del xi curl A I component. Because EI hat dot EJ hat is Kronecker delta IJ. All right. And now I'm going to write the I component of curl A. So this is equal to del xi I component of curl A epsilon ijk del ak del xj, which is epsilon ijk. This is just a number, so this the derivative doesn't do anything on it. I can take it up front. This is del xi del ak del xj. Okay, and I can now call ij and or ji. This is going to become epsilon jik del xj del ak del xi. All right. And the order of the derivative doesn't matter. So this is epsilon jik del xi del ak del xj. And once again, epsilon jik if you want to make it ijk, you're going in the negative direction, not clockwise. So this is going to be minus epsilon ijk, an odd number of reorderings here. This is minus epsilon ijk del xi del ak del xj, which is now telling us that x is equal to minus x, so x is 0. So what I have here, epsilon ijk minus epsilon ijk del xi del ak del xj. So first I renamed the indices, then I changed the order of the derivatives to show this. So this implies that divergence of curl of A must be equal to 0 as suggested. Okay, so in this part we have curl of gradient of f. For the del operator we have ei hat del xi, but this is the curl, so we have epsilon ijk ei hat, the j component of the gradient, which is del xj, k component of the gradient of f, which is del gradient of fk component, that's del f del xk. And now I have realized that I can change the order of the derivatives. It doesn't matter. So this is del xk del xj of f. And then I call k as j and j as k, so that this becomes epsilon ikj ei hat del xj del f del xk. And now I have the same order of derivatives here, but this is not epsilon ijk, it's epsilon ikj. What is the relationship between epsilon ijk and epsilon ikj? Because I'm going in the negative direction, so I have ikj. Now I'm going in the negative direction to write ijk, which is the counterclockwise direction, which is the clockwise direction. So this is clockwise, counterclockwise direction. Minus epsilon ijk ei hat del xj del f del xk. So this is the same thing multiplied by minus 1. So that means this must be 0. Now, as for the divergence of the curl, we have del xi ei hat dot product with curl a's j component ej hat, which is curl a. And ei hat and ej hat dot product is Kronecker delta ij, so I have curl a's ith component. Curl a's ith component is epsilon ijk del xj ak. And now I can take this outside because this is just a constant. Del xi del ak del xj. I have renamed I as j and j as I. So this is epsilon j ik del xj del ak del xi. The order of the derivative doesn't matter, so I changed the order. And epsilon jik is minus epsilon ijk, just like the previous case. So that means x is equal to minus x. So therefore, this quantity must be equal to 0. Divergence of the curl is 0.